Too loud? No. All right. So some of you saw me already. That's because this is the original talk, and the talk at 11 a.m. was switched because somebody didn't show up here. So this talk is about analyzing and predicting inner city parking space occupancy. The funny part is that the algorithm these guys showed the talk before is actually, I think, better than mine, because because I'm talking about traffic and about time decomposition, but I didn't use the good algorithms, so maybe I can use your stuff, or you can try my stuff. So why I'm here? I'm open data activist from Dresden. Dresden is in East Germany. If this is Germany, we are here in Berlin, and I'm from here, Dresden. And we, open data activists, try to free data. And this example is about what can happen if cities open their data to guys like us. So what we did is half legal. Like every first move in this area, the city of Dresden got an excellent traffic monitoring system. So they measure traffic everywhere in the city and show them up in the city for people driving with their cars. And that's the interesting part. They have a website where, hopefully internet is working, where they are pushing the free parking spaces all around the city live on there. So there is a website, they have the data, they are here, they are interesting for open data or citizen science people, but they don't provide an API, right? So like ever, data is there, but nobody can use it. So what we did, the Dresden open data activists, they wrote a scraper. That's a little program going to the website, collect all the numbers, store it in database, like you can see here on the flow chart. Website of the city, scraper programmed by us. Then we provide an API. That's the half illegal part. And some guys wrote an iOS app. It's named Parken DD for Dresden, and an Android app. And we provide a map which shows the free parking spaces. And my part was, and that's the part I'm talking about today, I tried to predict whether the parking space is free or is full. So what does it mean? You stand up in the morning, your kids take 1 or 2 hours to get ready. You want to jump in the car, drive in the city, look at your iPhone app, and it shows, all right, the parking space is full, crowded full. And we have the problem in Dresden. As you can see here, sometimes the parking spaces are completely crowded, so no free space. You don't have to drive with your car in the city. So that's an interesting thing. I think it's an interesting thing to know 1 or 2 days before, or 1 or 2 years before. Oh, that's fun. But you know, if the chief of the city of Dresden says it's not possible to give an advice where they should drive with their cars, you know what happened as an engineer? If somebody says it's not possible, let's try. So this code, and by the way, you can download everything. It's German. It's git clone, github.com, Mechlab Engineering, that's my company, and parkplätze.de, that's because in URLs you don't have the German letters. So Parkplätze are parking spaces. You can clone all the data and play with it. The first part is to get an insight. What is the data, to know something about it. So I don't get into any detail of any code line. So if you have a question what I did there, please raise your hand. If not, I will jump over a lot of these lines. So first is I read in the dump. The dump is provided by us, half illegal. So there are stored for every parking space in Dresden, let's say Zentrumgalerie, like the name said, it's in the center of the city. And there you have for every 15 minutes, that's the time difference. For every 15 minutes, you have the free space of the center. So 16.8% of the parking space is free. So let's check for missing data. We have here some missing data. Really, or actually 90% of the time there is no information for the parking space Flutrinne, but it doesn't matter. It's only if AC/DC is in Dresden. Then Flutrinne is opened. So we don't need, or I don't use any interpolation. So we skip this. I just using integers and limit it from 0 to 100%. So the data is clear now. And we can take some data visualization. This is, for example, Christmas on 2014. And you can see all men driving to the city. And this is the evening, 18 o'clock. And you can see this is where everybody is leaving the city. So the occupation of the parking space is rapidly down. Everybody is driving home. So Christmas, 18 o'clock, everybody is home. The parking space is completely free. 0% occupancy. So write some more visualization. That's the he left. That's the time decomposition he talked about. So that's the traffic, the real car traffic. He talked about server traffic. That's real car traffic. Probably I could use time series decomposition like in the talk before. I don't know these algorithms. Maybe I will try them. So you see from Monday to Friday, maximum 50% occupancy, and on Saturday nearly 100. So the parking space is full. So the mean for January, February, March, and so on, it's pretty boring. In case you are a center manager and want to compare your center against every other center in the city, then you will see that some parking spaces in these centers around the city are more crowded than the others. So you probably have a better parking garage than the others. It's important for women going to shop. My girlfriend, for example, is driving in the Zentrumgalerie, in the blue one, because they have the best parking house. And you can see she's not the only one. So if you open a center in the city, you know where the people are driving. So something in night, mean, it's just interested if you want to compare your parking house in the night. That's the maximum occupancy by week of the year. So every day, every week you have 100% in the Zentrumgalerie. And last but not least, I calculated a nice GitHub-like chart. So everybody who's contributing to GitHub, you know, this green map. And if you want to calculate something for this data. Here's the code. So here's the GitHub-like chart for the occupancy of the inner city parking space for the Zentrum Gallery for the whole year. You have here the weeks of the year. You have here the days, and I color coded like traffic light. So red is full, green is completely empty, and you can see on Saturday it's completely empty. But if Saturday is open, and that's not every day in Germany, it's crowded too. So right, this was the first part of the work. Just take a look in the data, get hands-on and something like that. And the second part, or the most important part, is, all right, can we predict how the people will drive into the city, or how many people will be in the city? And the question is, what are features who can describe if people are driving with a car in the city? And you know, I don't know the English one of that, but the German would be so ein Mist. Heute sind wieder alle in der Stadt einkaufen. So eine Blödmänner, ja. Also man fährt selber in die Stadt und es ist voll und man regt sich darüber auf. Also es gibt, there are days where a lot of people are driving to the city, and the question is, can we predict how many and what are the features? And the first part is the same. We load the data of the whole year. So we got a whole year from April 2014 to April 2015. And we're using this time series to do some machine learning with this year, and then we try to predict the future. So think about it, 1 second or a minute. What do you think are features who can describe if you are driving to the city and want to shop there? So that's right. There are. That's what I thought first. These maybe it's German. Sorry, I didn't translate it to English. These maybe features: time of the day, weekday. Is the Sunday open? Are school free? Something like that. So I tried to engineer these features out. I took this pandas code. So Python pandas is the tool of my choice. I took the weekday for every data point. I took the minutes past day, or the minutes of the day. So hour times 60 plus minutes. So I have a number which describes what time it is. Then I took the Sundays, the open Sundays in Dresden as a feature, and the Feiertage. Don't know what's the holiday. The holiday in Saxony. I used these days to as a feature. And last but not least, the shopping days to the next holiday. So, you know, if Thursday is open, Friday is closed, everybody is going to shop on Thursday. If Monday is closed, everybody is going to shop on Friday and Saturday. So you have some crowded cars in the city if there is a holiday. So I used shopping days to next holiday and shopping days after holidays as a feature. And that's my feature vector. That's my manual time decomposition, what these guys made, they talked before. That's my feature vector. And I tried some machine learning on that with, let's say, or think about it, all right, I don't I don't know every algorithm in detail, so let's try every. So, no, it's not in that way, but to show it on stage here, let's import every algorithm I know and let's test with it. So the good thing on scikit-learn is that you can do stuff like this. For model in every model you know, fit every model you know, fit your data, and calculate your time and calculate your accuracy score, and then you have a list. And you can choose fast or good and fast, or just fast. And if you have good features, maybe one or two or all algorithms are good. And because my label, I want to predict 0 to 100% for occupancy in the parking house, so my labels are 100, so a regression might be the best choice and not a classifier. So luckily the decision tree regressor have a very low prediction time, actually 0, and the first fit is okay, but you can read this. Think about if the prediction says 16% and the real value is 15% occupation of the parking house, it's wrong in terms of accuracy score, but it doesn't matter for real world. So the accuracy score is not the most important thing in this real case. So all right. The first decision was made. I take a decision tree regressor, but the second problem is I don't know every parameter of it. So I took a machine learning class, learned about it, and thought, all right, so the MacBook is so fast. Let's try every. Question? Yes. Is following. Yeah. So the try and error method for model selection was this, and the try and error method for parameter selection was this. So let's try some parameters, and you can see if my decision tree regressor is a very deep tree, so max depth to 20 depths in the regression tree, and at least 40 samples in one leaf, I get an accuracy score. Or no, I switch from accuracy score because I have a regression to this R² score because it's better classifier for regression problem. So I got 0.848 in R2 score. So let's fit with these parameters, and it's train test split. That's your question. That was your question. I made a train test split. I tested with I think 20% of the data. Yes, test size 20%. So take the whole year, shuffle it, take 20% out, and test with this 20%, right? So a good overfitting test, especially for regression tree, should be to test with your learning set and with your training set. And if you have a higher accuracy score with your training data, you overfit the tree, right? So it's just 0.1, so no overfitting. The most important feature is the time of the day. As you can see, time decomposition is in the night is empty, on the day is full. So the most important feature is the time, and second important, the weekday, because Saturday is so important. Then my both features, days after holiday and days before holiday, are important too. And this looks better on my laptop. You can see a slightly, that's the confusion matrix of what the algorithm predict and what is the real value. So a perfect algorithm has a straight line over here, and a randomly chosen, totally wrong algorithm will have dots all over here. So you don't see it on this chart, but you have here these values. So probably it fit pretty good. And all right, let's predict and compare. And here is the real value in blue and the green value estimated from the decision tree regressor in green. And you can see that you can predict if people are driving to the city with car and using this park house with just these 4 features. And the accuracy score is not this good, but it's, I think, enough to predict that on this time you don't have to use your car to drive to the city, because the algorithm can tell you, all right, probably 100% occupancy in the parking house. You don't need to use your car to drive to the city. And this feature went to the apps, Android and iOS app, so you can use the app to predict what is next week on Saturday at 9 o'clock. So we use this as open data scientists to help people. We have a lot of tourists from Czech. They're coming with car from Czech. And for them, it's important to know if in 1 hour when they arrive in Dresden, if the parking house is full and they can enter a new destination in their navigation system or not. And this feature or this algorithm will work, hopefully work for them. They have to know. So that's why I'm here to talk about. And now I'm pretty much ready and we can discuss.
Like this final task you did, like when they did train them, like I mean you predicted for July of 2014. But what did you take all the data stuff for that?
No, I took the same as him, which data I used to train. I took the whole year.
I understand the test train split, but
yeah.
You said like it's fine evaluation. You said, I think I remember you said you took the whole set to train the classifier, or did I misunderstand that?
Yes, I took the whole set.
So this part that you predict on was part of the training set as well?
I took the whole data set, shuffled it, and took 80%. So up or down? Up or down? You mean if I watched in the future?
Just this one line was we predicted for the whole data set.
Achso.
Well, the prediction was
a little bit
part of
further
the
up.
training.
There, via the whole data set.
I applied the prediction on the whole data set, right?
Yeah, so that's different from your cross-validation scheme that you did before.
Yes.
All right, so then back to my question, what training data did you use there in this scenario?
I used the whole year, shuffled it, took 80% to learn with it, calculated the accuracy score with 20%, so your trained test split, right? And then I used the trained classifier with 80% of the data to predict for the whole data set. So you're right, 80% of the learning data is in this.
So you basically predict about 80% of what you trained on?
Yes. And
So because it's just saying this might be like, if you test on the data you train on, it's not really a way to evaluate it.
That's because I made this test. I tested the model on my training data, and the accuracy score is bad. That means I did not overfit the model. And now I can, or I can push the accuracy score on 95%, and then I completely repeat the data set. That's what you mean, right? And I made it worse, yes, because then I can take a look in the future. So I created a data set, future data, yeah, in the future, and throwed in every feature with my model. And now you can take a look in the future, and as you can see, this is future. So the model can tell you on every day of the week how the parking space is occupied. So now I have to wait until this date, take a look on the data which is then coming in, and then I compare to my prediction, and then you have a real world accuracy score. That's for sure. What? For sure, for sure. You have in time decomposition, he said trending, and that's the problem. You have to take into part the trending thing. Now we have Primark in the Zentrum Gallery. That means you have some shift in the behavior of such a gallery, and so the data will never be this accurate like most guys of you need for Amazon prediction what the customer needs next. It will never be this accurate because inner city living is very complicated, and there are 1,000 reasons why people drive with car to this gallery, and I just have four general features, so it's not this accurate, but I think it's pretty okay for such a minor interesting thing like park space occupation. Yes.
You said you included days left in like the shopping week.
Yeah.
Do you have the results of the regression? I thought that was really cool. Do you know like how that affects, like if there's only 1 day left?
1 day left. Yes, you can see. For example, here are some predictions. So right, this is the feature vector, right? For the classifier predict 6 is let's take. So 6 is the weekday. It's Sunday. It's 15 o'clock. Open Sunday, 15 days to the next, and 1 day after. So if you have 15 days to the next shopping closing day, you have I have to load the whole data. Maybe you can wait a second. We can do it live. So the feature importance is this slide. Oh, we have to wait a second. I had a slide feature importance. Feature importance, is that your question, or do you want to see if you switch from 15 days to 1 day, how the...
Yeah, say you go from 15
Yes.
days to 1 day.
Yes. I can show this. If this notebook is... It's not this fast. So other question, I will test it. Other questions?
Have you tried your method on other German cities?
No, not even on other Dresdner parking spaces, because you have, really completely different behaviors. If you look at the time series of all the parking spaces, you have completely different behaviors of every parking house, because some are just for shopping malls, some are just for working people on the building next to it, some are just for events like AC/DC, and so you have to develop completely different features to predict the occupation. So this model might fit to every parking house in big cities with shopping mall next to it or in it. But I never tried because it is a lot of work to get it to get this work, and no time to try it with other parking spaces. So you see, so the feature importance was 10% or 11%. So if we switch from 15 days to the next to 1 day, then you got an increase of, you saw, from 16 to 48%. In this case on Sunday. So it means Sunday and Monday is closed. And this is an open Sunday. There? The open Sunday wasn't chosen from the classifier as an important feature. I don't know. Yes. There is no difference because I don't know why, but the classifier decided that the feature of Open Sunday is not important. I think it's important, but maybe there are just 4 days in the whole year which are Open Sundays. So the decision tree decided that this is not an important feature. So you will see if I switch to it's no Open Sunday, you have no change in this. Shopping days left. Shopping days left. No change. So magic. The most important feature is weekday and time. So the others are, because we have a whole year and there are like 4 open Sundays and like 3 or 4 days where under the week, so Tuesday is closed and then everybody is going to city on Friday. So these are just 3 or 4 or 5 days in a year, so it's not this important for the model. So that's why I said the time decomposition might be a good idea to try it with this traffic data. What's the time? 14? 14 minutes? We have 14 minutes. And then coffee. Yes, so another question, and then. The question was, would it be possible to use the same algorithm with satellite imagery data of cars in a city? I think 15 minutes. You see the gradient of cars driving in a parking house is very high. So if you're sampling every hour, you have a really bad starting base to predict the movement of the people in the city. Everything is online, yes. So you can correct my errors if you find a lot or some, or you can apply your algorithm. Like I said, we open data activists from Dresden. If you have a better method to provide a prediction of parking space occupancy, feel free to contribute. And the code and everything is under this address. And now, no more questions? One question? You know, as open data scientist or open data activist, you try to not show up in the server logs. That means not polling every second the city website, so no admin ever will see your URL in the server logs. And if it's the case, hopefully nobody will act against open data. So if you penetrate the servers just to have the API, they will ask you what you're doing there and what's your problem. So we ask in every 15 minutes, so maybe it's no server load for them, and so they are not interested in legal questions with us.
Yeah, maybe one question. As an activist, can you give us some insight in terms of what data you see already being available in Germany, and then also to compare it to a country like the US, where you have a lot more data publicly available from governments? Can you give us some insights, and also, what is the objective of your activism?
You know, the Google is pushing from the top, and we are pushing from the bottom. You know, we are Graswurzellobbyisten, wie man es auf Deutsch sagt, because there's Google funded in, and they provide us with website and stickers and stuff like that. And every open data activist in every city have to work for open data, and so Google is pushing from the EU, from top on the cities and on the government, and we have to ask from the bottom. And it's every time the same question. We go into cities and ask, hey, can you open this data set? And they are, why?
What kind of data can you give us some examples of what type of data you would like to see, and what will you see already some movements of city governments to make those data available?
Yes, one important thing is open Rathaus, that means open government, to push all relevant documents to websites, and so maybe you can add a ticker to your street. So if your Stadtrat will decide something for your street where you live or where you work is, like let's build an Autobahn. Yes, then maybe it's important that you are on the Planfeststellungsverfahren. You know, but the problem is they verabschieden it, and you will read. You'll read 3 or 4 years later about this, and then everything is over. So the interesting thing for the people is to open the documents, machine readable, to get informed about politics or something like that. The second movement is citizen science, temperature, light, smog, something like that, everywhere in the city, and collect the data, from the crowd, and then you have your own city sensor net. So that are the great lines on open data, from my view. But you know, I'm in East Germany. We don't see the world there. You know, there are a lot of labs, and we are pretty much connected, and you can read what everybody is doing. Yeah, some cities are very, very good, like Munich. I think Munich and Münster they have a lot of open data stuff, and we are fighting in Dresden for every kilobyte of open text from everywhere.
Any more questions? If not, then yeah.
Yeah.